So that means this is 1.16. This within bracket, the value is, sorry, this one. It is 4 pi plus 3 root 3 divided by 1.16. Here it is 2 pi plus root 3. 2 pi, this 1.16, 1.16 cancelled out. Only 4 pi plus 3 root 3 upon 2 pi plus root 3. This is the answer here. Let me write here. So final answer. So ratio is equal to, this is 4 pi plus 3 root 3 divided by 2 pi plus root 3. This is the answer here. Question number 14th, or question number 14 we have done here. Ratio of the areas of the loops, larger loop divided by smaller loop. This we have to calculate. Now this is the ratio here. Okay, so the answer. Now let me take next question. Question number 15th, or question number 15 here. What the 15th question say? 15th question. Let me talk about. Now this is, we are talking about areas of the curves by polar equations. So area of the curves by polar equations we are talking about. Okay, this is the first exercise in polar equations, areas of polar equations, or areas under polar equations, areas by polar equations, whatever. This is the area here by the polar equations we have discussed about. Okay, now 15th question let me talk about. Question number 15 says, okay, what does question number 15 say? It says that find the area of a loop of the curve. Okay, R is equal to here A into, what is this? A into cos 3 theta plus B into sin 3 theta. Okay, sin 3 theta. All right. Now, what is this kind of curve here? Now let me put solution. Now here, nothing is going to be, this curve is symmetric to pole or that, nothing. Only pi minus theta. Okay, if I put in place of theta, that will not change. Pi minus theta. Yeah, pi minus theta means it will be changed than cos theta. So it is not to be symmetric to anything. Symmetry is not to be defined here. Now let me put here, let me take A is equal to any constant value. If I take K is equal to, let me take C here, C into cos alpha, and B equal to C into sin alpha. Where alpha is any angle here, C is a constant here. So squaring them, this implies that squaring and adding them. So it is A square plus B square equal to C square into sin square alpha plus cos square alpha, and that is 1. It is C square only. So A square plus B square equal to C square, or C equal to under root A square plus B square. This constant value. Now if I divide this by this one, so C sin alpha divided by C cos alpha is equal to B upon A, or this is tan alpha. Tan alpha equal to B upon A. This implies that alpha, value of alpha is tan inverse B upon A. Okay, now if I substitute these values in this equation, this implies that R is equal to A we have taken C into cos alpha into cos 3 theta plus C into sin alpha into sin 3 theta. What is this formula? If I take C common, it is cos A cos B plus sin A sin B, that means cos of 3 theta minus alpha. This is this value here. So this is the same kind of equation which we can say it is cos 3 theta. If we start the initial line with angle alpha. Okay, then this equation, this one, the second equation, let me take. Then the equation will change to, and the equation will change to r is equal to c into cos 3 theta. Now if I trace this, so here it is 3 odd number, 3 is odd number, so there are 3 loops here. What are those loops here? Okay, so if I put r equal to 0, now let me trace them. This is of this kind of question. C we have taken already, that C is under root a square plus b square we have taken. So let me trace this equation. So this whole is converted into r equal to c cos 3 theta if we have started the initial line with alpha angle, because alpha is cos 30 minus alpha. Okay, so let me now trace this and find the area of the given curve. So what is that area? Let me find out this area. Putting r equal to 0, so we get c into cos 3 theta is equal to 0. Cos 3 theta is equal to 0. That means plus minus 3 theta equal. This is cos pi by 2. Because cos pi by 2 is 0. This is 3 theta is equal to plus minus pi by 2, 3 pi by 2, 5 pi by 2, etc. For this series of odd numbers of multiple of pi by 2, cos is 0. 3 theta equal to, therefore it is pi by 6 plus minus, it is pi by 2 plus minus, this is plus minus 5 pi by 4, 5 pi by 6, sorry, etc. Okay, so how many loops are there? So we will have the first loop here. There are 3 loops only. Pi by 6 plus minus pi by 6. This pi by 6, 30 degree to 30 degree. This line will be a tangent line, and within this line there is a loop. This is theta equal to minus pi by 6. Pi by 6. This is pi by 6 positive, theta equal to. Okay, now after that pi by 2. So from pi by 2 another loop will start up to 5 pi by 6. Okay, pi by 2 to 5 pi by 6. This is 5 pi by 6 here. And then another loop is here. So there's 3 loops here only. Okay, and tangent line, this is the tangent line at theta equal to pi by 2. Pi by 2, okay. And then pi by 6, this 5 pi by 6. 5 pi by 6 here. Then, 5 pi by 6. Pi by 2 and 5 pi by 6. 7 pi by 6. 5 pi by 6 is more than 180 degree. It means this value will be here. 5 pi by 6 is less than 180. Sorry, this is the same line here. This tangent line here. And then another line is this. This we are not to describe. Only area of this one loop. We have to find out area of this loop. And the area of a loop. This is a loop here. So area of this loop only we have to find out. Okay. Then we will replace C. C is there, constant. C will define the other values. Let me find out area of this loop. What is area of this loop? Let me take this as R. This is theta, d theta. With P and this is Q here. This is d theta. Okay, so area. This is initial line OS, and this is here. If I find out the value of R, so it will come out in terms of C here. That is not required. So this is the curve here. Okay, for value of theta, different value of theta, if I put value of R, then this curve will be traced out. Okay, so this is the loop of this line. Now let me take what is the area of this loop. Simple area of this loop will be, so what we have taken, r is equal to c into cos 3 theta. We have taken, this is the new loop here, which is described here. So loop between these two limits pi by 6 and this, so area of a loop of the above curve is equal to, now this is this area, limit between minus pi by 2, this is 1.2 minus pi by 6 to pi by 6 into r square into d theta. Okay, so this is equal to twice, let me take 1.2, 0 to pi by 6 limits. Here it is c square, sorry, this c square, r square is c square cos square 3 theta d theta. Putting here 3 theta is equal to, let me take 5. So d theta is equal to d phi oblique 3. And what are the limits here? Limits at theta equal to pi by 6. Phi is equal to 3 pi by 6, that means pi by 2. Okay, and at theta equal to 0, phi is also 0. So limits now, new limits are, okay, so let me find the area of this curve, this loop. This is nothing but twice 2 to cancel out, and limits 0 to pi by 6. This is c square, let me take outside now. C square is outside. Now this is cos, why is this is square only, I'm sorry. It's cos square 3 theta. Because square we have to find out. Cos square 3 theta. And 3 theta we have taken this angle phi, so this is cos square phi into d phi. Limits now are pi by 2, cos 0 to pi by 2, and this is d phi upon 3. 1.3 that we take outside. C square upon 3 we have taken, let me take outside. This is c square upon 3 here. This is c square d phi by 3, so 1.3 will also come out. So this is c square upon 3. So what is the value of this by reduction formula? So applying using a reduction formula. For cos here, we have discussed about reduction formula, a lot of things about that. So that's reduction formula for if limits are 0 to pi by 2, cos m theta or cos power n theta, whatever, into d theta is given for sine and cos. The reduction formula is applied. This is c square upon 3 into 1.2 into pi by 2. The value is, if power is 2, it is 1.2 pi by 3. Power is 4, 3 by 4, 1 by 2, pi by 2. In this way, the value is obtained. So this is equal to c square into pi upon 12. Okay, so pi c square upon 12, 2 to the 4, 4 to the 12. And c square is what? C square is a square plus b square, which is a square plus b square here divided by 12. So this is the final answer. Area of this loop is pi a square plus b square upon 12. Finally, this is the answer. Okay, so this is the process of finding the area of it. This is okay, cardioid shape. Alright, this loop is of the shape of the cardioid. We have taken this loop of this curve, which was of having odd numbers, so 3 loops were there. Only area of a loop we have to find out. Now, this is not a cardioid, but the loops were there. So 3 loops were there. Out of that, only 1 loop's area had to be calculated. Now, 16th question, let me talk about. 15th we have done. Okay. Now, 16th question, what is that? Now, question number 16 says, trace the curve. Okay, let me Write the curve first and find the area of a loop. All right. Trace the curve here. So curve is here. Curve is the curve. Here curve is r equal to root 3 into cos 3 theta plus sine 3 theta. Okay, this is the curve here. So solution. We have to trace this also. Solution. If I multiply this, let me take 2 into root 3 by 2, multiplying by 2 and dividing by 2, no problem. This is cos 3 theta plus 1.2 into sine 3 theta, no change. This is 2 into root 3 by 2 in case of cos is for sine 30 degree, sorry, cos 30 degree. So this is cos 3 theta into cos pi by 6 plus sine 30 degree is also 1.2. So this is sine 3 theta into sine pi by 6. Sine is cos b plus cos is sine b. This is equal to 2 into cos 3 theta minus pi by 6. Simple. Or if I take 2 into cos 3 common, so it will be theta minus pi by 18. Now here pi by 18, if we start the initial line with pi by 18 angle and putting theta equal to theta plus pi by 18, then the curve will change into 2 into cos 3 theta. So if we start the initial line with pi upon 18 angle, with angle pi upon 18, okay, pi upon 18, and putting theta as theta plus 1 upon, sorry, pi upon 18, considering theta as, okay, theta plus pi upon 18, then this curve will change into, or this theta or theta minus pi upon 18. So it will be, in place of this we will put here theta only. So this is 3 theta. That will give us, so the curve will be, therefore the curve will change into, the curve will turn into, the curve will turn into r is equal to 2 into cos 3 theta. In place of this I put theta. That means theta. This is minus theta here. R equal to 2 cos 3 theta. Now let me trace this. So tracing the curve here. So tracing the curve, this is 2 cos 3 theta. Now tracing this curve, putting r equal to 0. Okay, so that means cos 3 theta equal to again 0. Cos 3 theta equal to 0 here. Okay, so this is twice of this value, because here 2 is coming out as, yeah, so this value is 2 only. Cos 3 theta equal to 0. That means pi by, cos pi by 2, etc. That means 3 theta is equal to plus minus pi by 2, plus minus 3 pi by 2, plus minus 5 pi by 2, etc. Again theta is equal to, therefore it is pi by 6 plus minus, comma plus minus pi by 2. It is plus minus 5 pi by 6, etc. Again, the same type of loop as we draw in question number 15. Okay, so that kind of question will be there. This is x, O, y axis, y dash axis, x dash axis. Initial line is this. We have taken O as the pole and O OX as the initial line. So first curve will be between pi by 2 minus pi by 6 to pi by 6. So this is, let me take pi by 3, pi by 6, sorry. And this is theta equal to minus pi by 6. And this is theta equal to plus pi by 6. This is pi by 6 minus. So the first curve will be in between this. Okay, second curve will be between pi by 2 to pi by 6. So this is pi by 2 and this is pi by 6. And second will be this. So third one. There are 3 loops as we described in that. Okay, so this is how we can trace them, or we find out the value of theta. Okay, putting theta equal to pi by 6, pi by 2, etc. Okay, and finding value of r, then different values of twice multiplied with this will give us different values. So then we can trace them out. What is this value and this value also, that can be calculated. Okay, so this length and the curve will meet the initial line at this point. And what is that point? We can find out that putting theta equal to 0 here, theta 0, this is 2, it is twice here. Okay, and if putting theta pi by 2, it is 0 here, so it is 0, nothing else. 2 pi by, this is 5 pi by 6, 5 pi by 2, again it is 5 pi by 2. 5 pi by 2 means 5 pi by 6 here. So pi by 3, and again that value will give us, this is 2 to 1. The length of these curves is 2. Okay, so this is how we have to meet. This is 2, 0. R is 2 here, and yeah, R is 2 here. So this is R equal to 2 and theta equal to 0 at this point. Okay, here, so this is a tangent line here meeting at this point, okay, which is the y-axis in this case. So the curve is lying between minus pi by 6 to pi by 6, positive value. Area of this, one of the loops here, only one loop. Find the area, okay, trace the curve and find the area of a loop. Yeah, area of a loop, this is the tracing of the curve here. We can trace that. This we have done in curve tracing. Okay, lecture number maybe 79, sorry, maybe 80 or 79. Okay, those curves were the curve tracing was in 79, I think. There you can see. Yeah. Okay, now let me find out the area. Therefore, area of the loop of one of the loops here is equal to half one of the loops, limits minus pi by 6 to pi by 6. Okay, this is r square into d theta. This is formula, we know what. Limits we are given here, minus pi by 6, alpha is minus pi by 6, beta is pi by 6. We described initially that what is the polar equations curve, area of polar equation. 1.2 minus pi by 6 to pi by 6. Here in this case alpha to beta, r square d theta. Now putting the value of r square, minus pi by 6 to pi by 6 again, and here r square is this 2 into, so this is 4 into cos square 3 theta into d theta. Okay, this can be further written as 2 into 0 to pi by 6. Okay, this is 4 also has come out. So this is 2 to the 4, sorry, 2 to cancel out, 4 only, 4 times. This is 0 to pi by 6. And here it is cos square 3 theta d theta. So putting 3 theta equal to 5, let me take. Putting 3 theta is equal to 5, differentiating with respect to 5. So we get 3 d theta is equal to d phi, or d theta is equal to d phi oblique 3 Okay, limits. What are the limits then? Limits at theta is equal to, let me write here limits. Find out limit here. Limits at theta is equal to pi by 6. Phi equal to 3. Theta means pi by 6. 3 2 ja, that means pi by 2. So phi is pi by 2 at theta equal to pi by 6. And at theta equal to 0, phi is also 0. Here 3 theta. Theta is 0, so 3 into 0, 0, so phi is also 0. The limits are 0 to, this is 4 times, let me write here. So therefore area is equal to now 4 times, because 2 to cancel out. So it is 4 into area required. Area of a loop is equal to 0 to pi by 2 now. Because limits are now 0 to pi by 2. This is pi by 2. And it is cos square phi into d phi by 3. This is the value. Okay. Let me now further solve it. So we obtain this as 4 by 3. Let me take 3 outside. So this is 0 to pi by 2 cos square phi d phi only. What does it give us? Now by using reduction formula from 0 to pi by 2 cos square theta or whatever. So this is 1.2 into pi by 2 formula also. Since 0 to pi by 2, okay, sine square theta, or let me take n theta, is sine m theta d theta is equal to m minus 1 upon m. In this way we write m minus 1 upon m, m minus 3 upon m minus 2 here, etc. Okay, so in this way, and finally it is 1.2 into pi by 2 up to this point. So this is the value of reduction formula. By this reduction formula we have applied this. This is 2 minus 1 means 1 upon 2, then pi by 3, last one. These last values we have come out. So 4 cancel out, this is only pi by 3. So answer of this question is pi by 3. 16th question is done. So area of the question number 16 of the given loop is pi by 3. Okay, square unit is not given, but only limit, this unit we have to write here, pi by 3 is the answer. Square unit we can write because this area, so area is always expressed in square units. Let me take now 17th question now. Question number 17, what did it say? Okay, so question 17, 16 we have done. The last question here. So what is question 17th? Talk about. It says find the area of the portion included between the cardioids. Okay, so cardioids given here. Cardioids are, what are the cardioids here? Okay, so first is R is equal to A into 1 plus cos theta. This is first equation. R is equal to second is A into 1 minus cos theta. This is the second equation. Yeah. R equal to A 1 minus cos theta. And the first is R equal to A 1 plus cos theta. What is this position here? Here we are given these cardioids. And these questions we have described, isolatedly, this one and this one. In question number second, okay, this is the second question. This second question we have described here in third question. With the tracing of the curve there, that was the cardioid. Okay, and then ninth question, ninth one. Ninth question is find the area of the cardioid R equal to A 1 plus cos theta. Same. So here these two are combined together. What is the area here? Now if I describe them putting R equal to 0, and these two are symmetric to the pole. Why? Because theta is replaced by. So let me find the solution. These two curves are symmetric about the initial line. Why? Because if I replace theta by minus theta, because cos is even function, so it doesn't change, the curve will not change. Initial line as if theta is replaced by minus theta, then the curve does not change. The curve remains unchanged or does not change. Because of that, it is symmetric about initial line. This is one of the points here. Okay, so these two curves will be, then if I find, let me find the first one. Similarly with second, find out tracing. For tracing, if I put r equal to 0, so let me take the first one. Putting r equal to 0. Putting r equal to 0. R equal to 0 there. It is cos. So r equal to 0. That means cos theta will be equal to minus 1, which is cos pi, cos 3 pi, etc. Therefore, theta is equal to pi, 3 pi, and odd number of pi. For pi it is minus 1, 3 pi to negative 1. Okay, so this, if I put theta between these limits, then what is the value of r? We have to find out. So r minus 1, r is 0. Okay, it starts from 0. Then if I put 2 pi, at 2 pi it is positive 1, so it will be 2. Okay, so at 2 pi, means pi, if I put 2 pi here, so from 0 to 2 pi, so these, okay, limits are, let me describe them. What kind of this curve will be? So first, this is the cardioid of the first one, this plus 1, 0, 0, we start from 0, 0, okay, because at pi by 2, it is 0 here. Theta is pi by 2, it is 0. Sorry, at pi, it is 0 here, because minus 1 is 0. So r equal to 0 at pi, this is here, theta is equal to pi. At 0 it is 2, it is twice a. This length is twice a here, it is at theta equal to 0.